Okay, ladies and gentlemen, we've talked about the standard polar curves. Well, we have curves that we've already done. We have ellipses, circles, hyperbolas, parabolas, etc. So whether it's limosone, whether it's cardioid, whether it's lemniscate, etc., those are fancy curves that we need to know a little bit about, but so are the other conics that we've already done. Now, the challenge is moving those conics back and forth between the two versions. In this case, we have a whole bunch of conics over here that you can take a look at. So for example, numbers 18 through 25, 18 through 25 over there, those are conics, but you wouldn't recognize them in that form. Now, the book goes through an entire discussion of general equations based on eccentricities between foci and directrix, etc. I don't want to get into it. I'm going to just use these, and we're going to be able to change these into their traditional forms. Now, to do that, the best way we can do this is write down our equation. And go to work on it. How do I convert this into something else? Now, this would be easy enough to change. I could say r equals the square root of x squared plus y squared equals 4.8 over 1 plus, the problem is I have no r here, so we end up with, since it's y equals r sine theta by itself would equal y over r. Well, that's not really what we want, because y over r, I still have r's mixed in with this. I could replace r with the square root of x squared plus y squared, but look at that nasty, horrible fraction. So this is not something we want to take on in that form. Our big problem is all these denominators. So what we need to start with is, let's start by getting rid of some denominators. If I put that over 1, I can cross multiply. R times 1 plus sine theta equals 4.8. Not too shabby. I can give away the r. R plus r sine theta. Now I like that a lot better. 4.8. I can replace r now with square root of x squared plus y squared. Still don't love that square root, but it's not too shabby. In this case, r sine theta is nothing but y, so that works out very nicely. And now I have all y's and x's. Not too bad. So, let's see what we can come up with here. I want to get rid of the square root, but if I square both sides as it is, that's easy, but this is going to be a mess because I would have to FOIL. I certainly don't want to FOIL, so let's subtract y from both sides. Square root x squared plus y squared equals 4.8 minus y. Now if I square both sides, I get x squared plus y squared equals, now I get 4.8 times 4.8 because I would need to FOIL this. So first times first, 23.04. Twice the cross product, so minus 9.6y plus y squared. At this point, I can subtract y squared from both sides, and I have x squared equals 23.04 minus 9.6y, and that is obviously a parabola because I have one squared term, one non-squared term. If we wanted to make it a bit more standard, I could even take out the negative 9.6 And that leaves y, take out a negative, so it'll be negative 2.4. Center is at 0, comma negative 2.4. I can find my p-value. I can graph the equation. This is the process that we would go through to change from something that's in polar to something that's in rectangular. Quick review. We got rid of the denominators by cross multiplying. We plugged in what we could from our 4 key formulas, got everything in terms of x's and y's, and simplified it down. Okay, ladies and gentlemen, here's taking a look at your homework. You need to do a couple specific problems that are like each of the problems in your book. You're going to have to go from polar equations to rectangular form, be able to graph things, tell what they look like, what shape they actually are, and then again be able to convert from equations into polar form. So I'm going to give you a couple for homework, and this is the type of bookwork that you're looking forward to when you return to class. Okay, here's your homework piece. You have 3 problems here, numbers 1, 2, and 3. Make sure you change those from polar form to rectangular. So get after those and bring them to class.